you get one more data point. But on the other hand, we can also provide input to LHC. For example, what we have done, we have measured, just to show you one slide, we have measured the proton-proton cross-section at 50 TeV. And I think I have that slide here. This is a measurement we have done. So you see here, look at the lower graph here, that's a proton-proton inelastic cross-section, one fundamental observable, which is important for our simulations also, as a function of square root of S. So these are the LHC data. One of them published in Nature even, but I think by Atlas, or one published in Nature. This is Atlas, CMS, and LHC, and Totem. And you see they are here, these points, and this is the Auger point, which is at 57 TeV. And the uncertainties are a bit larger than that, but on the same scale, I would say. And these are the statistical and the systematic uncertainty. And we can go to higher energies. We only went here to this energy of 57 TeV because in this case we know from the composition studies I just showed that at this energy they are primarily protons. So we are not affected by systematic effects. And but in the future, if a good selection of data can be done, we can go to up to 100 TeV even. And this is in progress. So at the next ICRC we will present data at higher energies. So, and that's important because you don't know how the cross-section, actually you see these were the uncertainties of the model. There were some models predicting a strong increase of the cross-section. And so that's apparently not the case.
Okay, so question.
I think your detector is too large.
Too large?
Yeah, too large, especially for the extinction, extension. Okay, what's my question is this, I know that there is the output for the northern telescope, the observatory. Okay, but this I'm not asking that. What's your expectation, of future experiment 20 years later?
Yeah. Maybe I don't have this slide here. Let me just check what our plans are. Oh yeah, here are our plans. I mean, oops, no, it's not that. So I mean, what we do presently, I don't know whether that's written correctly. I mean, what we do here at presently is Auger decided that we do an upgrade and improve the precision of the measurement. Telescope array decides to do an enlargement to be also close to 3,000 square kilometers, which is very sensible because a telescope array suffers more from statistics. We suffer more from, say, we have reasonable statistics for what we want to do, but we want to improve now the quality of the measurement to do this mask-enhanced anisotropy studies. So therefore, I think it's a good complementary approach by telescope array and Auger for the upgrades presently pursued. And this is then the next step, which is in the European roadmaps by now, which is understood that worldwide, I mean, including people from telescope array and Auger and GEMI-U, and so on. A next step, I mean, to have with simplified techniques, a next generation of, I mean, we dream then even of 90,000 square kilometers, which is then distributed at a couple of different locations in the northern and southern hemisphere. So it doesn't have to be one location in the north and one location in the southern hemisphere. And so this is a project then of 400 million in total, and we are working on this, I mean, for the next generation jointly. So this is the next step really after the upgrades. And that you need, maybe I just say that, because you may ask why you need a larger observatory. What we may see, and in fact there are indications that even at the highest energies we have about 10% fraction of protons. And then what we want to do is proton astronomy at the highest energies. That means, I mean, if you just have 10% of the flux is protons, and then if you want to do source studies, I mean, you need 10 times larger observatory. So that gives you from 3,000 you go to 30,000 square kilometers, and then, I mean, you have this factor of 3. So there's a rationale behind.
Next one.
What's the mass factor which limits the resolution?
There was a question here first, sorry. You're next.
Could you show me your weak hotspot?
Okay. No, wait.
or a few percent effect, right?
Something is wrong now. Okay, here we are. Sorry.
Yeah, I remember that your latitude is around 36.
Our latitude is 36 degrees, yes.
So I think your hotspot is
Just above us.
the zenith.
Yeah, close to the zenith, yeah.
I may ask you what kind of correction of the pressure effect or climate effect?
Oh, yeah, that of course is done. I mean, I didn't mention here, all the data that I show are of course corrected for pressure effects. Doesn't play a big role at these high energies, but at the threshold for anisotropy studies it plays a big role, not for the rest. So this is done carefully, and I could show you offline, I mean, all these plots, I don't have it in the store.
So it's a 100% level, systematic side.
Depends on, I mean, for this particular analysis, for this plot, it's below percent, I would say.
0%.
Yeah,
You control the climate and pressure percent level.
So we do, we have continuous atmospheric observations, and I always used to say that the most careful studied atmosphere on the globe is on this 3,000 square kilometer in Argentina. And we have enormous industry of atmospheric observations. I can tell you.
Okay, last question.
So what's the main factor which limits the resolution? And have you reached the natural limit?
The resolution on which quantity?
On direction.
On the direction, or the arrival direction. The resolution I didn't mention here is 0.6 degrees, the angular resolution. And this 0.6 degrees is basically given by the timing uncertainties in the shower front measurement. And we didn't aim to improve that. I mean, we didn't want to make it worse. I mean, because all the effects that we measure are on the scale of a few degrees, the correlations, not at a sub-degree level. So we felt that the 0.6 degrees of angular resolution is good enough for our purpose. You could improve it in principle, but the question is whether you would invest your money in an improved angular resolution or say in an improved composition or energy resolution.
Well, but if you really want to pinpoint the source.
Or if we have a source, at that point we will start to improve the angular resolution.
Okay, so there is still a possibility to
Yeah,
improve.
you can. But it's just a question of what you think. I mean, what is most important, and
Well, but I think at a certain point, the fluctuation in the atmosphere dominates. So there is a natural limit.
yeah, you cannot go to 0.1 degrees, but you can improve from 0.6 degrees. But as I said, presently there is no need, and probably there is also no need in the future, because I don't think even for protons, if you were able to select protons at the highest energies, you always get deflections on the scale of 1 degree. And
Okay.
unless the magnetic fields are very weak, weaker than we think. And at that point, there will also be no need in the future to try to improve that. In principle, there is some room for improvement, but not by a factor of 10, sure.
Yeah.
Okay, let me still ask the.
Oh, it's not the last question.
Next question. Well, Nature News had some posting statement, I think, last fall.
Yeah.
So, being a spokesperson, what is the official response to
Well,
this?
this was very unfortunate. There was an article in Nature. Actually, I helped that lady, Katja, to go to the observatory to talk to people, and she totally messed it up. And she excused herself that some sentences were changed after she did the last editing, and the impression that was given was completely different from what the intention was. So it was really understood by some people that Auger were to close down, which was never any intention to do. And since it was, she wanted actually to emphasize the fact it would be a mistake to close it down. That's why she mentioned it that often. And it just went, I mean, backwards, right? It was firing backwards. I mean, at least it was a matter of how you understand the article. Some people said, oh, it was fine. I mean, in the community outside of OG, but some other people say, what are you intending to close down? And so it was really unfortunate. The article was unfortunate. So next time I told her, if you write something again, I will proofread the very last word.
Okay, let's thank Professor Kampert again. For those interested, the